Hello viewers, welcome to another question by Martin Tutorials. A reminder, I have two YouTubes, Martin Tutorials Variety and Fun Math. As always, free to subscribe and a full refund with a subscription if you're not happy. That's such a great deal. On to today's question. What I love about math is all the interesting questions, how they do solve real problems in real life. I always think to myself, hey, this will be a great question to do. Let's do it. And this is one example. I'm sure this question has appeared in other places, but I just thought of it yesterday. Let's do this question. And the question is as follows. We have a circle divided into 4 segments using 5 vertical lines. The 2 outermost lines are tangents to the circle. The 3 inner lines pass through the circle. This is the important part of this question. The lines have the same distance between them. The distance between all lines is equal. What proportion of the circle's area do each of the 4 segments represent? Can make 2 statements. If I did it each one as a fraction of a circle, I will bet if I add up the 4 segments, I should get 1 because they all add up to the full circle. That's if I let the circle's area equal 1 and I'm doing it as a proportion of 1. And also, I believe I just need to find one segment. The rest is easy. The circle is symmetrical, so everything to the right is 0.5. Once I solve for this segment, 0.5 minus the segment gets me that one. And everything is symmetrical, so it will be the same on the corresponding segments. So to begin with, I'm going to start off with just this segment. I drew this diagram. This segment I want to calculate, I'm going to call it B, all right? And what I also did, I drew a line extending from that center point to the ends of the line where it touches the circle. I call that A. First of all, B relative to the circle as a fraction is B's area divided by circle's area, which I wrote. Proportion of area B that's relative to the circle is area B divided by area of circle. Okay, and I'm going to make another statement. This area with a triangle and this little segment B, and we have to be careful. I'm not going to call this a semicircle. It's not a semicircle because those lines haven't reached the top. But what I will say is this entire shape of A plus B, if I subtract A, it will give me B. Makes sense? 2 parts, simple words, 2 parts, subtract 1 part, gives me the other part. The area of B equals the area of A plus B minus the area of A. There we go. So what I'm going to do now is find the area of A plus B and the area of A, then I can subtract them. Area of B, what it is, I take the circle's area and I find out what fraction of the circle it is. So I'm going to be naughty in that I'm going to first fill in numbers and then explain. Area of a circle is pi r squared. Now to get this segment, I'm going to multiply by 120 over 360. And I'm going to explain why. This is r, the radius of the circle. From this point of the circle is also r, it's a radius. The lines are the same distance apart, so from this point to this line is r over 2. There's my diagram, there's r over 2. This is a famous triangle with proportions 2 and 1 and a 90 degrees. That's the triangle with 60 degrees. Or I can take my calculator, I say the cos of what gives me 1 over 2, work backwards. And either way, I get that 60 degrees. And if this is 60 degrees, then the 2 little portions added together is 120. The entire circle is 360 degrees. This angle is 120. So the proportion relative to the circle is 120 divided by 360. So so it's the area of the circle multiplied by 120 over 360. That's the same thing instead using radians. 60 degrees is 2 pi over 3 radians. And the full circle 120 degrees is 2 pi over 3, and 360 degrees is 2 pi, and it's in proportion. I'll get the same answer either way. The area of A times B, 120 over 360 simplifies to 1 over 3, and this also, 2 pi over 3 divided by 2 pi will also simplify to 1 over 3. So the area of A plus B is pi r squared divided by 3. That's this whole area over here. Now to work on area A. Area A is a triangle. The one formula for the area of a triangle is half AB sin theta. In this case, A and B are both radius, so it's half times r times sin theta, which is half r squared. And we already solved from before what's, actually we haven't solved yet what's the sin of 120. The sin of 120, there's my diagram, is like using related angles is like saying the sin of 180 minus 60, which is the same as saying the sin of 60. And the sin of 60 is root 3 over 2. And there's my diagram. There's 120. That's 180 minus 60. And in this segment, it's always positive. So it's plus root 3 over 2. And there's my root 3 over 2. So it's half r squared. Sin of 120 is root 3 over 2. And when we simplify the arithmetic, we get root 3 over 4 r squared. Now to get back to our equation, area B is the area of A plus B minus the area of A. We solve for both. The area of A plus B is pi r squared over 3. And the area of A is root 3 over 4 times r squared. And this gives me the area of B. Now, area of B related to the whole circle, as I said earlier, is B's area divided by entire area, which I wrote over there. So this I just rewrote. This is the equation for the area of B. We divided by circle's area. Area B relative to the circle. So this equation divided by pi r squared. And now we simplify. First step, I can divide everything by r squared from the top and bottom. We get pi over 3 minus root 3 over 4 divided by pi. And how we simplify depends on personal taste. If you feel confident with a calculator, you can just punch it in the calculator. I happen to times top and bottom by 12 to get rid of these fractions. So I land up with 4 pi minus 3 root 3. If you multiply by 12, 12 over 4 gives me 3. Divide by 12 pi. I punch in the calculator, I get 0.1955. Okay, so there's 0.1955. This is half a circle. So this will be 0.5 minus 0.1955, which gives me 0.3045. And the two sides are symmetrical. So from left to right, it's 0.1955, 0.3045, 0.3045, and 0.1955. And something interesting, the question says, what portion of the circle's area do each segment represent? I always go back and check that my answer fits the question. Maybe the numbers are right, but did they say what percentage or it says what proportion? So to me, that is correct. I could rewrite it in percentage, but this fits the way they asked the question. I appreciate that you watched today. Please click subscribe and let me know any other questions you'd love me to do. Talk to you all soon, and there's all my papers put together. And I especially use these papers so I can move them around. It's easier to refer to them when I need them. See you all soon.